In January 2022, a bridge in Pittsburgh collapsed while people were driving on it. Not a rusty old footpath, not a back road in the middle of nowhere. A four-lane city bridge carrying rush-hour traffic. And the thing is, engineers already knew something was wrong. They had it on a list. They kept it open anyway. Right now, there are bridges across the United States, bridges you may have driven on, that are sitting on the same kind of list. Federally flagged, documented, and still carrying thousands of cars every single day. The government has a phrase for it. They call it structurally deficient. Sounds like a paperwork problem. What it actually means is inspectors found something wrong, and they decided closing it would cost more than monitoring it. Here are 10 bridges where that calculation is still playing out, right now under the wheels of drivers who have no idea. Number 10, the Hernando de Soto Bridge, Memphis. You've probably driven across it if you've ever taken I-40 through Tennessee into Arkansas. It's the one that drops you over the Mississippi River, wide and flat and brown underneath, and the drop is far enough that you'd have time to think on the way down. In May 2021, the whole thing shut down with no warning. Not a slow closure, not a gradual weight restriction. One inspector on a routine survey found a crack running almost the entire width of a main support beam. Traffic was rerouted within hours. The crack had been growing inside the steel, invisible from outside, invisible during every inspection for years. And here's the thing about fracture-critical bridges. There's no backup system. If that beam goes, everything above it goes with it. 50,000 vehicles cross this bridge every day before the closure. 50,000 people who had no idea they were driving over a single cracked beam with nothing else holding things up. The bridge reopened after repairs, but the same inspection system that missed the crack for years, that hasn't changed. Number 9. The Brent Spence Bridge, Cincinnati. This one isn't cracking, it isn't rusting, it's just being used in a way it was never designed to handle, and has been for decades. The bridge was built in 1963 for about 80,000 vehicles a day. It currently carries more than 160,000. You can feel it when you're on it. The lanes are narrow, the merge is tight, and there's a steady background noise of trucks that makes the whole deck feel like it's vibrating under you. Because it is. Every single crossing adds stress the original engineers never accounted for. Metal doesn't forget. Every heavy truck, every degree of temperature expansion, every cycle of load adds to a cumulative fatigue that can't be inspected away. This bridge carries roughly 3% of the entire country's freight GDP every year. One serious incident shuts a corridor that connects the whole Midwest. A replacement has been announced, funded, delayed, re-announced, and delayed again since 2012. Most drivers crossing it today don't know they're on a bridge that was already obsolete before most of them were born. Number 8. Louisiana's bridge network over the Mississippi Delta, and specifically, the danger you cannot see from the road, from the water, or from any inspection platform. It's called scour. The river current moves against the bridge piers, the legs holding everything up, and slowly, over years, eats away the soil underneath them. The foundation shifts, you'd never know from above. By the time it's visible, the pier is already moving. Scour is responsible for more bridge collapses in the United States than any other cause. More than rust, more than age, more than any event you could name. Federal studies estimate more than half of all bridge failures in this country involve foundation scour in some form. And not all bridges in scour risk zones have underwater monitoring sensors. Some of them are checked by divers, manually, on a schedule, in murky river water, with limited visibility. That's what's standing between the bridge above you and the riverbed below. Number 7. The Dames Point Bridge in Jacksonville, Florida. From the road, it looks fine. The cables are still there. The structure is intact. But if you look closely at the main support cables, you'll see it. Rust stains running down the concrete, orange streaks spreading from where moisture has been getting in. Most people see that and think, surface rust, cosmetic issue. Here's what they don't realize. Rust on a bridge cable doesn't stay on the surface. It moves inward through individual steel wires you'll never see unless someone physically cuts the cable open. And once it's deep enough inside, there's no practical way to reverse it. Florida DOT inspections have rated the cables as satisfactory. But satisfactory covers a wide range of actual conditions, and it doesn't tell you how far inward that rust has already gone. Cable-supported bridges are among the most expensive infrastructure projects in the world to replace. Cities don't replace them until they have to. The question is always, how close is too close? Number 6. The bridges above the New Madrid seismic zone. Most people driving across the Mississippi River in Missouri, Illinois, Arkansas, or Tennessee have never heard of New Madrid. Here's what you should know. In 1811, an earthquake centered in this region was so powerful it reversed the flow of the Mississippi River temporarily and rang church bells in Boston. The fault is still active. USGS models estimate a major event here would collapse more than 3,500 bridges across the central United States. And most of the bridges currently sitting above this fault line have zero seismic reinforcement. Not because engineers forgot, but because the bridges were designed and built before anyone understood there was a serious fault underneath them. The specific danger isn't just the shaking, it's what happens to the ground. Water-saturated river soil turns liquid during a major quake. Bridge piers that have been standing perfectly still for 60 years suddenly have nothing solid holding them. There's no retrofit for that. The fix is a full foundation replacement. Most of these bridges are still waiting. Number 5. The I-35W Bridge, Minneapolis. August 1, 2007. Rush hour. The entire bridge, 8 lanes over the Mississippi River, carrying 140,000 vehicles a day, fell into the water in under 10 seconds. 13 people were killed. 145 were injured. When investigators finally figured out what happened, the answer wasn't an earthquake, or a flood, or some freak event. It was a design error that had existed in the original 1960s blueprints. Small metal connector plates called gusset plates had been undersized from day one. The bridge had been carrying that flaw for 40 years. Here's what makes it worse. Visual inspection, the kind used on almost every bridge in America, can't detect an undersized gusset plate. It looks fine. It looked fine every time an inspector walked across it. After Minneapolis, the federal government identified more than 750 other bridges with similar concerns. Most of them are still standing. Some of them you've crossed. The inspection checklist that missed Minneapolis. It's still largely the same checklist in use today. Number 4. The Manchac Swamp Bridge and bridges like it. Long concrete spans over open water, where the enemy is invisible and works from the inside out. Salt water and moisture penetrate concrete over time, reach the steel rebar inside, and start it rusting. The rust expands. The expanding rust cracks the concrete from within. You can see it in the spalling, chunks of surface breaking away from the piers. Some engineers will tell you the deterioration on these structures is surface level. Others will tell you the only way to know for certain is to core sample every single pier. The Manchac Bridge has nearly 9,500 piers. Nobody has tested every one of them. And here's what nobody says out loud. There is no instrument, no sensor, no inspection method currently deployed on this bridge that would give you advance warning before a pier fails under load. There is estimation. There is professional judgment. And there is the bridge, still open, still carrying traffic every day. Number 3. Rural bridges across the Midwest and South. The ones with the yellow weight limit signs you've probably driven past without reading. 40% of rural bridges in the United States are weight restricted. But during harvest season, modern combines and grain haulers regularly exceed those limits, legally, through state-issued permit exemptions that allow oversized agricultural loads on posted roads. The bridge doesn't know about the permit. The sign says 15 tons. The machine weighs 35. Every overloaded crossing does damage to that structure that is exponentially greater than a legal weight vehicle. One overloaded pass can equal hundreds of normal crossings in terms of stress on the deck. This has been happening on the same bridges for years. State transportation departments know. Agricultural lobbies in multiple states have successfully blocked enforcement. Rural bridge deficiency rates are more than double the national average. And the county road crew responsible for the bridge might not have the budget to assess it until it's already showing visible damage, which by then means it's been failing invisibly for a long time. Number 2. The Francis Scott Key Bridge, Baltimore, and every bridge like it. In March 2024, a container ship lost power and drifted into the Key Bridge's main support pier. The bridge collapsed in seconds. 6 construction workers were killed. The ship wasn't speeding. The crew sent a distress call. There was simply nothing between the ship and the pier capable of stopping or deflecting that much moving weight. Protective barriers around the pier, called dolphins, had been considered during the original 1970s construction. The cost was deemed too high. The decision not to build them is documented in the original engineering review. It wasn't a secret. It sat in a file for 50 years. After the collapse, the federal government reviewed major U.S. bridges over active shipping lanes and identified dozens that lack adequate vessel collision protection. The review is ongoing. The retrofits, which can cost up to $200 million per bridge, are not scheduled. The shipping lanes are still active. The bridges are still there. And here's what ties all of this together. The problem isn't that engineers don't know which bridges are dangerous. They have lists. Detailed federal lists, updated every 2 years, with ratings and categories and recommended actions. The bridges in this video are on those lists. Most of them have been on those lists for years. But structurally deficient doesn't legally require a bridge to close. It requires it to be monitored. The Federal Bridge Inspection Standard is more than 50 years old. It is still, at its core, a visual system, an inspector walking across a bridge and looking at it. The American Society of Civil Engineers estimates the backlog of bridge repairs in this country at $125 billion. The annual federal allocation is around $5 billion. At that rate, the math doesn't work out. 25 bridges collapse or have serious failures in the United States every year. Not all of them make national news. The ones that do have one thing in common: they were already on the list.